Good morning, ladies and gentlemen. Today we will talk about double replacement reactions. And double replacement reaction, if you remember, it is about exchanging of partners here. And so like A is with B, and C is with D. Okay. A and C being the metal. So metal, and then B and B mean non-metal. Non-metal there. So what they do is these two first guys switch places. So now C is with B and A is with D. Okay, there is a switcheroo here, a double replacement, double displacement, double replacement. You'll see a lot of that happening. Okay, and as we know, sometimes it works, sometimes it doesn't. So how do we know when this actually happens? This happens if and only if on the product side over here has one of three things. It produces a solid, a liquid, or a gas. Okay, it has to produce one of those three things in order for that to happen. And another word that you'll see very often is AQ. That's aqueous, means it is dissolved in water, dissolved into ions. If it's dissolved into ions, it doesn't form a new compound. It just hangs around there. So then the reaction does not happen if this is aqueous and this aqueous it does not happen. This reaction does not occur. But if this reaction is a solid here, then yes, it occurs. If it's a gas, if it's a liquid, then this reaction occurs. So knowing that, you have to know if something's a solid or something is aqueous. Is it solid? It does not dissolve. Or is it aqueous? Dissolve into ions. Okay? So, is it solid or aqueous? And how do we know that? We know that based on this list right here, this chart here. This solubility, the common solubility rules here. Alright? And so we already know that activity series over here, this is used for single replacement reaction. And this middle chart is for double replacement reaction here. Okay? So keep that in mind. Single replacement, use activity series. And with activity series, you also have the nonmetals. Fluorine over chlorine over bromine over iodine. That order for the halogens. But on the other hand, double replacement, you use this right here. Okay? How do we use this? These are the rules telling you that, for example, on the top part here, focus on the top part, these are soluble. So all these are aqueous over here. If it's an exception, that means it becomes a solid over here. For example, this is soluble, this is aqueous, except, like bromine, it is soluble except when it's with Ag. So if it's AgBr, that's a solid. If it's PbBr2, it's a solid. If it's HgBr2, it's a solid as well. I'm sorry, H2Br4. Something like Hg with Br, it's going to be a solid. Anything else, NaBr, aqueous. Anything else, everything else would be aqueous. So something else, AlBr3. So anything with Br is aqueous over here. Remember, all this over here is aqueous. And this part over here are the exceptions, which makes it solid. Okay. Everything with acetate here, C2H3O2, everything with that is aqueous. Everything with NH4, anything that has NH4, NH4Cl, aqueous. NH4NO3, aqueous. NH4 2SO4, aqueous. So anything with NH4 is aqueous. Same thing with NO3. Anything with NO3 is aqueous. Anything with CN, ClO2, ClO3, ClO4. So everything there, these guys here, they're all aqueous. So if you see a compound with them, they're going to be aqueous. They're not going to stick together. They're not going to remain a solid. Okay? So the bottom part here is the reverse. This is insoluble, means these will be solids. Oops, let me move that. Okay, the bottom part here, this is insoluble. So these are the exceptions to them. The exceptions are over here. So that's what makes this aqueous over here. Alright, notice, anything with NH4 is aqueous. That makes sense because up here the NH4 rule, everything NH4 is aqueous. So if you see an NH4 with any of these guys, that'll make it aqueous. And then also alkaline metals. Notice alkaline metals. And where are alkaline metals? Alkaline metals are these guys right here. Li, Na, K, Rb, Cs, Fr. These are alkaline metals. Where they're with these guys, Li2CO3, LiPO4, LiCrO4, LiCr2O7, LiOH, KOH, all that. So basically, anything with alkaline metals here is going to be aqueous. Alright? Some examples. Look at this. You look at MgCO3. Right? You look at CO3 there. You look at the rule for CO3 here. CO3 is insoluble, so we assume that it's insoluble means it's a solid. Alright, is Mg NH4? Nope. Is Mg alkaline metal? Nope. So then this stays a solid. If it's an alkaline metal like Na2CO3, you ask, is it a solid? Right. So it's CO3. Most CO3 are not soluble, so most of them are solid. But because it's with alkaline metal here, it makes it aqueous. So this is aqueous. Alright. So how do I apply this? You have a paper, it looks like this. Actually, you have a paper before this that looks like that. Go through this one and identify whether or not it is soluble. Is it solid or aqueous? Okay. So for example here, Na2, a couple ones you should cross out. We don't have the rule for that. We don't have the rule for SO3 either on this chart. So if you see SO3 somewhere, you can cross it out. I think you'll see it down here again on number 7 here. But number 7, let's assume that that's aqueous, okay? Because it actually is. Okay, so CuNO3. And what do you look at? You either find copper or you find carbon or nitrate. And there's nitrate on the list. Here's nitrate. Where is it? There it is. Nitrate. Soluble. So it's aqueous. Every single nitrate is aqueous. So you can go find any nitrate on here, it's aqueous. Okay. MgCO3. CO3. Mg, I can't find Mg, so let's look at CO3. There it is. We did this one earlier. CO3. Is it with NH4? Nope, it's with Mg. So, is it with an alkaline metal? Nope. So it stays a solid. NH4Cl. All NH4s are up here. They're all soluble. They're all aqueous. So that's aqueous. NaCl. There's no Na, so look for Cl. Cl here. It's aqueous, right? Except when is it with Ag? Nope, it's with Na. It's with Na, so it's not none of these, so it stays aqueous. So go through, figure out if it's aqueous or solid. You have to know how to do this in order to predict the reaction of double replacement reactions. Okay? And so you go down here to the bottom, And you figure that out as well. H2SO3, that is aqueous as well, because really all acids are going to be aqueous. Okay. KCl. KCl, it is aqueous. So you note it here, aqueous, 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 aqueous. And for a reaction to occur, we have to have solid, liquid, or a gas in the product. So do we have any of those in the product over here? No. So then this one, no reaction. Nothing happens really. Okay? They're dissolved in water. They're just hanging around. They don't form any new compounds. All right, and so let's go back to like number 1. Na2SO4. So we look at the list for SO4. SO4 is aqueous. BaCl2, see, that's aqueous. NaCl, that's aqueous. BaSO4. So now look, SO4 is right there. Okay? Ba is an exception. It's soluble, but with Ba it's solid. It stays solid. So that BaSO4 is a solid, and so this reaction will occur because it has a solid on the product. So look at the product side. There's a solid. Okay? So you go through, complete this, and on the very next page, it's a little more complicated here because you have to write the product. Okay? And it's not too bad. The product here, you look at the metal. Remember, it's the double replacement, the metal switches. So you switch them anyways, and then you determine if it's solid or aqueous, and you tell whether the reaction occurs, and then you balance the equation as well by putting coefficients. Okay, switch the negative ions, or the positive, it doesn't matter. But if you switch the positive, switch the negative, switch only the negatives. So Li jumps over here, Ag goes over there. Ag now is with Ag2S because the sulfur is -2. Sulfur is -2. Ag is +1. So then it's Ag2S plus Li is +1, NO3 is -1, so it's LiNO3. Okay. So now we check the solubility rules. Okay, let's check our solubility rules. And AgS, is AgS solid or aqueous? Get a brand new one here. S here is insoluble. Remember, S here is insoluble. Is it with NH4? No. Is it with Ag? Right? It's with Ag. So it's not an alkaline metal. It's not calcium. It's not that. It's not that. So it stays a solid. So that's insoluble. LiNO3. NO3 is there. They're all soluble. So this is aqueous. So this reaction will occur. And then I'll balance these. Okay. Balance these by putting coefficients in front. I just look, there's NO3, there's Ag2, there's 2 Ags there, so I put a 2 there for 2 Ag. Now that makes it 2 NO3s as well, so I put a 2 there for 2 NO3s. Then I have 2 Lis, 2 Li, 1S, 1S. Good. So it's 1, 2, 1, 2. That's your coefficients there. So go through, switcheroo the metals. You can do that. So Na goes with Cl, NaCl, Na is +1, Cl is -1, NaCl. Plus Ba is +2, CO3 is -2. So then BaCO3. Okay. Next, you determine if it's solid or aqueous. NaCl. All chlorides are aqueous. Sorry. BaCO3. Let's look. CO3 I don't remember quite well, so let's look here. CO3. It's insoluble except with NH4 and alkaline metal. Is barium an alkaline metal? Nope. Is barium NH4? Of course not. So this one stays solid, insoluble. Okay, solid. So then that's how you do the reaction there. Balance these suckers. 1Ba, 1Ba. 2Cl, 2Cl there. And that's it. 1C, 3 O's. Good. 1, 1, 2, 1. Not bad. Yeah, most of the balancing here is fairly simple. It might look complicated, but it's fairly simple. Let's do one more. 10. Zinc. Zinc and Ba will switch place. So Ba, NO3, 2. Both Ba is +2 and zinc is +2. So then it's kind of easy here. Plus ZnOH2. So it's already balanced. If you look at it, it's already balanced, so it's nice. So BaNO3. Remember, all NO3s now. I did enough. Now remember, everything with NO3 is aqueous. Now OH. That's one I haven't ran into yet. So let's go find OH here. There it is. Okay. OH is insoluble. That means it's solid. Remember, unless it's with these guys. Is zinc in this exception list? Zinc is not alkali metal. Zinc is not any of those. So no. So it stays a solid. Zinc stays a solid there. There you have your double replacement reaction. Okay. If you run into a situation where it's the product side is aqueous and aqueous, that means no reaction. Okay, no reaction. It's not going to happen. So it has to have a solid, liquid, or gas. That's the end of today's video. Please finish this paper, and I should have a review ready for you to complete, and there will be a test next class after the counselors come in. So bye bye.